Welcome to this model. And this model we are going to see about the domain name system. There are several applications in the application layer of the internet model that follow the client-server paradigm. The client-server programs can be divided into two categories, those that can be directly used by the user, such as an email, and those that support the application programs. The domain name system is a supporting program that is used by other programs such as email. Now let's see an example. What is you can see here. So what you see here is an example of how a DNS client server program can support an email program to find the IP address of an email recipient. A user of an email program may know the email address of the recipient. However, the IP protocol needs the IP address. The DNS client program sends a request to the DNS server to map the email address to the corresponding IP address. To identify an entity, TCP/IP protocols use the IP address, which uniquely identifies the connection of a host to the internet. However, people prefer to use names instead of numeric addresses. Therefore, we need a system that can map a name to an address or an address to a name. When the internet was small, mapping was done by using a host file. The host file had only two columns, name and address. Every host could store the host file on its disk and update it periodically from the master host file. That was done in the earlier days. When a program or a user wanted to map a name to an address, the host consulted the host file and found the mapping. But today, however, it is impossible to have one single host file and relate every address with a name and vice versa. So the host file would be too large to store every host. In addition, it would be impossible to update all the host files every time there was a change. So one solution would be to store the entire host file in a single computer and allow access to this centralized information to every computer that needs mapping. But we know that this would create a huge amount of traffic on the internet. Another solution, the one used today, is to divide the huge amount of information into smaller parts and store each part on a different computer. So in this method, the host that needs mapping can contact the closest computer holding the needed information. So this method is used by the domain name system, DNS. So in this model, we are going to discuss the concepts and idea behind the DNS. Now let's speak about what is namespace. To be unambiguous, the names assigned to the machines must be carefully selected from a namespace with complete control over the binding between the name and IP addresses. The name must be unique because the addresses are unique. The namespace that maps each address to a unique name can be organized in two ways, that is flat or hierarchical. In flat namespace, a name is assigned to an address. A name in this space is a sequence of characters without structure. The names may or may not have a common section. If they do, it has no meaning. The main disadvantage of flat namespace is that it cannot be used in larger systems such as the internet because it must be centrally controlled to avoid ambiguity and duplication. So we go in for hierarchical namespace. So in a hierarchical namespace, each name is made of several parts. The first part can define the nature of organization. The second part can define the name of the organization. And the third part can define the departments in the organizations and so on. So in this case, the authority to assign and control the namespace can be decentralized. A central authority can assign the part of the name that defines the nature of the organization and name of the organization. The responsibility of the rest of the name can be given to the organization itself. So the organization can add suffixes or prefixes to the name to define its host or sources. And the management of the information need not worry that the prefix chosen for a host is taken by another organization because even if part of an address is same, the whole address is different here. So for example, assume two colleges and a company call one of their computers Challenger. The first college is given a name by the central authority such as fhda.edu. Then the second college is given the name as berkeley.edu, and the company is given the name smart.com. So when these organizations add the name Challenger to the name they have already been given, the end result is three distinguishable names. That is challenger.fhda.edu, challenger.berkeley.edu, challenger.smart.com. So the names are unique here without the need for assignment by a central authority, and the central authority controls only part of the name, not the whole. To have the hierarchical namespace, a domain namespace was designed. So in this design, the names are defined in the inverted tree structure with a root at the top. Let's see the structure. So this is what the structure of the domain namespace, and the tree can have only 128 levels. That is level 0 to level 127. Each node in the tree has a label which is a string with a maximum of 63 characters. The root label is a null string, and DNS requires that children of a node, that is nodes that branch from the same node, have different labels, which guarantees the uniqueness of the domain names. And each node in the tree has a domain name. A full domain name is a sequence of the labels separated by dots. The domain names are always read from the node up to the root, and the last label is the label of the root. This means that a full domain name always ends with a null label, which means the last character is a dot because the null string is nothing. So, and we have some domain names list that we'll be seeing in this. And fully qualified domain name is a label. That is, if the label is terminated by null string, then it is called fully qualified domain name, FQDN. FQDN is a domain name that contains the full name of the host. It contains all labels from the host specific to the most general that uniquely define the name of the host. For example, the domain name challenger.atc.fhda.edu is a FQDN of a computer named Challenger installed at the Advanced Technology Center ATC at D. Anzo College. A DNS server can only match FQDN to an address. You can notice that the name must end with a null label because null means nothing. The label ends with a dot, that is dot symbol. So if a label is not terminated by a null string, then it is called a partially qualified domain name, that is PQDN. A PQDN starts from a node, but it doesn't reach the root. It is used when the name to be resolved belongs to the same site as the client. Here the resolver can supply the missing part called the suffix to create an FQDN. For example, if a user at the fhda.edu site wants to get the IP address of the Challenger computer, he or she can define the partial name. The DNS client adds the suffix atc.fhda.edu before passing the address to the DNS server. The DNS client normally hosts a list of suffixes, and the suffixes can be like what you see here as the any type of label we can suffix, right? A domain is a subtree of a namespace, and the name of the domains is the name of the node at the top of the subtree. Now let's see some domains, some examples of domain. You can notice that a domain may itself be divided into domains or subdomains, as they are sometimes called. The information contained in the domain namespace must be stored. However, it is very inefficient and also unreliable to have just one computer to store such a huge amount of information. It is inefficient because responding to requests from all over the world places a heavy load on the system, and it is not reliable because any failure makes the data inaccessible. So the solution to this problem is to distribute the information among many computers called DNS servers. That is, let's see. So this is a hierarchy. One way to do this is to divide the whole space into many domains based on the first level. In other words, we let the root stand alone and create as many domains as there are first level nodes. Because a domain created in this way could be very large, DNS allows domains to be divided further into smaller domains, that is subdomains, and each server can be responsible, that is authoritative, for either a large or small domain. In other words, we have a hierarchy of servers in the same way as we have a hierarchy of names. So since the complete domain name hierarchy cannot be stored on a single server, It is divided among many servers. What a server is responsible for or has authority over is called a zone. We can define the zone as a contiguous part of the entire tree. If a server accepts responsibility for the domain and doesn't divide the domain into smaller domains, the domain and zone refer to the same thing. And the server makes a database and called a zone field and keeps all the information for every node under that domain. However, if the server divides its domain into subdomains and delegates part of the authority to other servers, and the information about the nodes in the subdomains is stored in the servers at lower levels, with the original server keeping some sort of reference to these lower level servers. Of course, the original server doesn't free itself from responsibility totally. It still has a zone, but the detailed information is kept by the lower level servers. A server can also divide parts of its domain and delegate responsibility, but still keep the key part of the domain for itself. So in this case, its zone is made of detailed information for the part of the domain that is not allocated and references to those parts that are delegated. So a root server is a server whose zone consists of a whole tree. A root server usually doesn't store any information about domains but delegates its authority to other servers, keeping references to those servers. There are several root servers, each covering the whole domain namespace. The servers are distributed all around the world. Thank you.